Well, yeah, I gave you the 2 points. So what does our equation gonna look like? Y equals A times B to the X. That's an exponential, so we gotta remember that, because that's what we're shooting for now. So your job is to find the A and the B. Jake?
Plug in the point with 0 in it.
Yep, so we start here. Oh, so I see what you were saying, Jake. You know the points are 0, 10.
Yeah.
Yeah, I thought you were being a smart ass.
No.
Yeah, okay, I got it. Yeah, so those are our ordered pairs. So I gave them to you in function notation, but those are the ordered pairs. So Jake says, start with the one with the 0. Is this starting to sound familiar?
Yeah.
Start with the one with the 0. Remembering that that's X and Y. So 10 equals A times B to the 0. Then remember what's so cool about this? B to the 0th is 1. So this just says A equals 10. So now if we know A is 10, then we know Y equals 10 times B to the X.
And then plug in the other point.
And plug in the other point. Come on now, this sounds familiar. We're gonna plug in the other point. So 45/8 equals 10 times B to the second.
Yeah.
Okay. How do I go about solving that?
Would you?
I gotta get this by itself, so I'm gonna have to,
45/8 divided by 10.
I'm gonna have to divide both sides by 10 or multiply by 1/10. Won't that accomplish the same thing?
Yeah.
Might be easier since there's a fraction involved, but it's completely up to you. You gotta get rid of that 10. So B squared ends up equaling 45/80. Let's see if that reduces. 5 goes into both. Let's see, 5 goes 9, 5 goes, oh my gosh, 16. How perfect is that?
That's really good.
Because now we're going to square root, and B is 3/4. Now don't get so excited that you forget your job was to write the equation. So Y equals 10 times 3/4 to the X. That is the equation. Okay? We're gonna have a test the end of next week. We still have some work to do in the chapter, but there's a lot here to keep track of, so put a star next to that. I know that's a test question. Okay, let's look at number 3, because we haven't done that one yet. We start with this equation. Okay. Let's stop for a second. This is one of your BFFs. Which one is it? It's the exponential. And we know that the exponential normally looks like this. This is what the exponential looks like. This one's a little different though. This would be a picture of a growth function. Is this a growth problem? No, this is a decay. So this shape is going to be this way, the general shape. I'm not done with it yet, but that's going to be the general shape of it.
Yep.
The directions say find the y-intercept and horizontal asymptote. So I know it has this shape. The normal y-intercept would be 0, 1, and the normal asymptote would be y equals 0. Okay, let's talk about how we get our y-intercept. Again, this is the normal. This has got some changes to it. How do you get a y-intercept? You let x be 0. Okay, let's let x be 0 in this problem. Okay, what happens if I put a 0 there? 1/2 to the 0 is 1. 15 times 1 is 15. And then the whole shebang goes down 1, so it's actually at 0.14. I'm gonna start over here. So my y-intercept is at 0.14. Now, my normal asymptote is supposed to be at 0, but what have I done in this picture? I brought everything down 1. So my asymptote is actually down here at -1. And then, oh, it's going down, sorry. It looks like this. Now, you didn't have to graph it, but you had to find the y-intercept and you had to find the asymptote. So how do we find a y-intercept? No matter what the equation is, we find a y-intercept by letting x be 0. Okay? Asymptote of every exponential starts out at 0, and then you can either raise it or lower it by putting a number on the end of it like this. Okay, let's do one more from this page, and then we'll move on. The second part of that. This is not an exponential. This one is a logistic equation. And do you remember what the general shape of a logistic is? Remember, it has an asymptote here and an asymptote here, and it goes like this. Remember that? So this one's going to have 2 asymptotes. The bottom asymptote, unless we have done a +5 or something in the end, the bottom asymptote is always going to be at 0. How do I find the top asymptote? It's called the limit to growth. Where does that come from? The numerator, right? Don't you remember that, guys? This number is your limit to growth. So this asymptote is 12, and this one is 0. Logistic functions have a ceiling. It's called the limit to growth. And the limit to growth comes from that. All right, now how do we get a y-intercept again? Let x be 0. So if I put a 0 right here, what's going to happen? Well, that's going to become 1 times 3 plus 1 makes 4. 12 divided by 4 is 3. So your intercept is at 3. Hang on to that sheet. And we'll finish it maybe tomorrow or another day. We'll get that wrapped up before we take the test. Make sure we do some reading. Okay, but I know you've been waiting for this moment. We still have one more massive problem to do in section 3.5. So, yesterday, we did number, or letter G. This is on the back of page 37. Yesterday we did G, today we're doing I. Don't panic, they're done exactly the same way. So, does anybody remember from yesterday how we started?
Times by 2.
Multiplied this 2 to the other side. Perfect, Amanda, that's exactly what we did. Okay? Anybody remember what we did next? Katie?
Would you make the second one 1 over u?
Exactly. We don't like negative exponents. We don't don't like negative exponents anytime, anywhere except scientific notation. So we're gonna rewrite that as 1 over e to the x. But now we have another fraction. We don't like those either. So we'll multiply by e to the x. So now we have e to the x times e to the x plus 1 equals 8 e to the x. Katie?
You have to move 8 over 8 e to the x and then let u equal e to the x.
Exactly. So we're gonna have, this is e to the 2x, because we add the exponents, minus 8e to the x plus 1. And then this is where you just gotta think about this for a second. This is the same as e to the x twice, e to the x squared. And when we think about it like that, we're gonna do exactly what Katie said. We're gonna let u be e to the x. This u substitution thing, which is a huge part of our study of calculus. Not this particular problem, but this concept. So then, if u is e to the x, then I've got u squared minus 8u plus 1. Right? And it's solvable with the quadratic formula. So u equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Eight plus or minus the square root of 60. Keep an eye on my arithmetic. Did I do that right? So now I'm going to get a couple of decimals, but I'm going to get two u values. U is either going to be 8 plus the square root of 60 divided by 2, 7.8730, or 8 minus the square root of 60 divided by 2. 0.127. So I let u be e to the x, solving this quadratic, got this, which I then typed into my calculator, the plus and the minus version, and those are the numbers I got. I hope someone else got those. Is anybody else typing this in, or are you all zoned out? Thank you. Now, don't put those in the answer blank though, because those are u's. Your job is to solve for x. So e to the x is 7.8730. Or e to the x is 0.1270. How do you solve?
Log.
Actually, I think I'll LM, take the logarithm of both sides, the natural logarithm. And what happens when we do that? This is so cool. What happens?
The e cancels.
All that's gone, so what does x equal? Either ln that or ln this, right? This time we're going to get two answers. They're both okay. ln 7.873. So I got 2.06 for one answer. And then ln 0.127, negative 2.06 for that one. Those problems problems on monsters. If I give you one of those for like a grade, it'll be a bonus. Okay, because they're tough. They're tough.
Why is like the negative 2.06 an answer and not like up here when there was a negative?
Okay, you gotta remember what you're doing. That, when we did this yesterday, one of our U values came out negative.
Oh.
That's a different situation, right?
Yeah.
Because I can't take the logarithm of that, but I can take the logarithm of a positive. And remember, this x value is an exponent. Can exponents be negative?
Okay.
Whew, I'm hot. That wears me out. All right, are we okay? Everybody all right? Okay. Now you gotta get pumped up, because now we're gonna look at something that's gonna be required of you. We're gonna do some word problems. There are going to be several formulas in this section, 2 of which you're required to memorize. The rest of them, if I want you to use them, I'll give them to you. Okay? The 2 that you're gonna memorize, and I would suggest maybe in your notes, you write them right up here at the top where you got some room, you've seen before. Have you seen this formula before? We call it the PERT formula for obvious reasons. And then this one. These are the 2 you have to have memorized. Do you remember seeing that one before? No? I'm pretty sure you have, but you may have forgotten it. Now I'm going to read the first question. How long will it take for an investment of $1,000 to double if the bank pays 2.5% interest compounded quarterly? That's the key. This is our compound interest formula. You will only use this formula in money problems where the interest is being compounded a certain number of times. So compounded quarterly means 4 times a year. We could do compounded monthly, we could do compounded daily, weekly. Anytime you have that situation, that's your formula. Now, what do all these letters stand for? A stands for the end amount. That's what, however much you're gonna end up with. P is how much you started with. You may have heard of the word principal. When you go to the bank, you invest your principal. That's your original investment. What did you start with? That's a 1, the number 1. This is the interest rate. Now, when you put that into the formula, it must go in as a decimal. So if it says 3%, you put in 0.03. Got it? It's not going to work otherwise. And there are 2 of them. They're the same number. That is the number of times per year that you compound. So in our problem, since we're compounding quarterly, N will be 4. And then T is the number of years. So, let's see if we can plug this in, and this information in, and solve this. Do I have an A value? Do I have an ending amount in problem 1? Meg? 2,000. Meg is a genius because she read the problem and it says I want my investment to double. So since I am starting with 1,000, then I'm going to end with 2,000 if it's doubling. What's my interest rate? 0.25. 0.025. I'm dividing it by 4, raising it to the 4 times t. Do I know my years? No, isn't that the question?
Yeah.
Isn't that what I'm looking for? Now, little anticipation is building here, because as soon as I put my variable up there, I know I'm gonna need logarithms to solve this. So at some point in the game, I'm gonna put logarithms in, okay? Probably not first. What do you think I should do first? Divide by 1,000? Absolutely. You do not want this number hanging around. You're gonna get rid of that number. So in this case, it's super simple. I'll divide it 2. Now what do you think? Anya?
Solve for inside parentheses.
So Anya wants to clean this up right here, or maybe make it a number instead of all that gunk. And that's okay, Anya. I never want you to round that off though. So as long as you can do it, and I'm gonna check right now to see if I can. Oh yeah, as long as you can do it without rounding it off, then go right ahead if that makes you feel more comfortable. I think we've put it off as long as we can. We need to take the logarithm of both sides. Now, I don't care if you LOG or LN. It doesn't make any difference. There's no benefit to LNing. There will be in this formula. But here, it doesn't matter to me if you log or LN. It makes no difference whatsoever. We need to get the logarithm in there somehow. Why do we need to get the logarithm in there? Because that's gonna take this guy right here and put him out here, right? Which is where I want him. So the log of 2 equals 4t log 1.00625. Is everybody still with me? Now, this is what you're solving for. So how are you gonna get him by himself? Nyla? We're gonna divide both sides by 4, so we're gonna take log 2, close parentheses, divided by 4. And then what? Don't I also have to divide by this guy?
Yeah.
So now I'll do divided by log 1.00625. And that's going to be my t value. So we're going to back up and talk about that. It's about 27.81 years. To get t by itself, we have to take this right here and divide by 4. So I did that, divided by 4. And then I have to take whatever that is and divide it by that. And I did that in a second step and got this answer.
Would it be fine if you did divide the log 1.00625 before you
Oh,
divide
absolutely,
Okay.
absolutely. You can divide them both at the same time as long as you put them in parentheses.
Okay.
Yeah. Okay? All right, next problem. Number 2. Gotta decide, is this gonna be the right formula for problem number 2?
Yes.
If you're saying yes, you're right. How do I know? What is the key wording in the problem? Compounded monthly. Compounded monthly. So, what does problem number 2 look like? Do I have an A? That's my question. Do I have a P? 1, 2, 3, 0. What's my interest rate? 0.03125. What's my N? 12 monthly. So there's a 12 up here also. That N appears twice. And how many years? 10. Am I gonna need logarithms for this problem? No way. You only need logarithms when your X is up here. Now, personally, I always multiply my exponents. I'm gonna make that a 120 before I get started. You don't need to do that. I just always do it. And I'm just gonna type this in. Just type it exactly the way I wrote it. I would really love it if somebody else besides me would type it in, so we can kind of check each other. $1680.53 is what I got. Nothing fancy. Type this in. That's all you have to do. No division, no logarithms, no nothing. Type it in. Those are the best kind. Anybody else get that?
Yeah.
Perfect. All right, we're gonna talk about this next formula, and then I'm gonna quit boring you. Let's read question 3. What's different about question 3? It's not money, right? It's not money. So there's no way you're using this formula. This formula is used for one thing only, and that is compound interest. If it's not money, we're not using it. So that means we're using this one. This is called your continuous growth formula. It is used for all non-money, so whatever it is, whether it's population, radioactive decay, whatever it is, if it's not money, we're using PERT. But we also use PERT if it's a money problem and our interest is compounded continuously. So if you read a money problem and it says this, PERT is your formula. Compounded monthly, compounded quarterly, that's the other one that I just erased. But if it's compounded continuously, then we're gonna use PERT. Or if it's any kind of nature problem, this is called the continuous growth formula. Any kind of like situation that isn't money. So here we go. We'll do this one and then we'll be done. How long will it take? Oh, I gotta tell you what all these things mean. A is what we end with, and P is what we start with. It's exactly the same as before. R is called the growth constant. In a money problem, that's the interest rate, but these are not money problems, so it's called the growth constant, and T is your time. So here we go. How long will it take for a population of 450 geosites to double if their growth constant is 0.123? Do I know A? What is it? 900. Because P is 450. Do I know R? 0.123. And my variable is T, which means at some point I'm going to need logarithms. What do I do first?
Divide by 50.
So 2 equals e to the 0.123t.
Natural log both sides.
I'm going to natural log both sides because,
Because we have an E.
gone. So ln2 equals 0.123t. So what am I going to do to get t?
Natural log 2 and then divide that by 0.123.
Bingo. Don't forget to close your parentheses after the 2. ln2 divided by 0.123. Looks like it's about 5.64. I don't know, it doesn't really say in the problem. Days, years, months, weeks, minutes, some unit of time, right? So it'd be 5.64 time units. You guys are wonderful. Good job. Good job. Remember the 3.5 homework is due tomorrow?